So let's practice counting atoms. This slide asks us to count the number of atoms of each element on each side of the arrow and determine if the equation is balanced or not. The first equation is coefficient 6, capital C, capital O subscript 2, or 6 molecules of carbon dioxide, plus coefficient 6, capital H subscript 2, capital O, or 6 molecules of water, arrow, capital C subscript 6, capital H subscript 12, capital O subscript 6, or 1 molecule of glucose, plus coefficient 6, capital O subscript 2, or 6 molecules of oxygen. The second equation is capital S, lowercase n, capital O subscript 2, or 1 formula unit of tin 4 oxide, plus capital H subscript 2, or 1 molecule of hydrogen. Arrow, capital S subscript n, or 1 atom of tin, plus capital H subscript 2, capital O, or 1 molecule of water. The next equation is coefficient 3, capital C, lowercase a, capital C, lowercase l subscript 2, or 3 formula units of calcium chloride, plus coefficient 2, capital N capital N lowercase a subscript 3, capital P, capital O subscript 4, or 2 formula units of sodium phosphate, arrow, capital C, lowercase a subscript 3, parentheses, capital P, capital O subscript 4, end of parentheses, subscript 2, or 1 formula unit of calcium phosphate, plus coefficient 6, capital N, lowercase a, capital C, lowercase l, or 6 formula units of sodium chloride. Pause the video to determine if these equations are balanced. To count atoms, we multiply the coefficient by the subscript for each element. Looking at our first equation, let's count carbon first. On the reactant side, carbon is found in carbon dioxide and has a coefficient of 6 and a subscript of 1. 6 multiplied by 1 is 6 carbon atoms on the reactant side. On the product side, carbon is found in glucose and has a coefficient of 1, and carbon has a subscript of 6. 1 multiplied by 6 is 6 carbon atoms, so carbon is balanced. Next, let's look at oxygen. Oxygen is in every single chemical in this equation. On the reactant side, we multiply the coefficient of carbon dioxide of 6 by the subscript of 2 for the oxygen, which is 12, and we add the oxygen from water, which is the coefficient of 6 multiplied by the subscript of 1 for a total of 6. 12 plus 6 is 18 oxygen atoms on the reactant side. On the product side, we multiply the coefficient of glucose of 1 by the subscript of oxygen 6, which is 6, and we add the oxygen from oxygen, which is a coefficient of 6 multiplied by a subscript of 2 for 12. 6 plus 12 is 18. So our oxygen is balanced. Last, let's look at hydrogen. On the reactant side, hydrogen is in water. We multiply the coefficient of 6 by the subscript of hydrogen 2 for a total of 12 hydrogen atoms on the reactant side. On the product side, hydrogen is in glucose. Multiplying the coefficient of 1 by the subscript of 12, we end up with 12. Since each element in this equation has the same number of atoms on each side of the arrow, this chemical equation is balanced. Looking at our second chemical equation, let's start with tin. On the reactant side, we multiply the coefficient of 1 by the subscript of 1 for tin for a total of 1 tin atom. On the product side, we multiply a coefficient of 1 by a subscript of 1 for a total of 1 tin atom. Tin is balanced. Let's look at oxygen next. Multiplying a coefficient of 1 by a subscript of 2, we get 2 oxygen atoms on the reactant side. On the product side, we multiply a coefficient of 1 by a subscript of 1 to get 1 oxygen atom. This equation is not balanced. For the sake of completion, I counted the hydrogen atoms too, but once an equation is unbalanced for one element, the entire equation is unbalanced. Our last example has a polyatomic ion, phosphate, on both sides of the arrow. If a polyatomic ion is on both sides of the arrow, you can balance the polyatomic ion as its own entity rather than breaking it down into its constituent elements. It just makes the job of balancing easier. Let's look at calcium first. Even though calcium exists as a cation, we will refer to it as an atom when we balance. I hope this doesn't confuse you. In the context of balancing, the charge doesn't matter. A coefficient of 3 is multiplied by a subscript of 1, which gives us 3 calcium atoms on the reactant side. On the product side, a coefficient of 1 is multiplied by a subscript of 3, yielding 3 calcium atoms. Calcium is balanced. On the reactant side, a coefficient of 3 is multiplied by a subscript of 2, yielding 6 chlorine atoms. On the product side, a coefficient of 6 is multiplied by a subscript of 1, which gives us 6 chlorine atoms. Chlorine is balanced. On the reactant side, a coefficient of 2 is multiplied by a subscript of 3, which gives us 6 sodium atoms. On the product side, a coefficient of 6 is multiplied by a subscript of 1 to give us 6 sodium atoms. Sodium is balanced. On the reactant side, a coefficient of 2 is multiplied by a coefficient of 1. There's only one phosphate ion in this formula, gives us 2 phosphate ions. On the product side, a coefficient of 1 multiplied by a subscript of 2 gives us 2 phosphate ions. Phosphate is balanced. Since all elements are balanced, this equation is balanced. You will be expected to balance unbalanced equations. To do this, you have to be able to count the atoms to determine if the equation is unbalanced. Sometimes coefficients of 1 are balanced chemical equations, so you have to know how to count atoms to balance chemical equations.